Here, we can also use a simulation to deepen your impression. We use a serial circuit of a voltage source and RC to illustrate the half-power frequency of the LP filter. About how to use a multisim to display the transfer function of a circuit, we have discussed in the introduction of Simulation 6. Here we use it directly. Simulate, analysis, AC. The start frequency is 1 Hz and the stop frequency 100 kHz. The logarithmic horizontal axis coordinate. The output we set is V2 over V1. The transfer function of the circuit is the ratio of the capacitor voltage and the supply voltage. We click Simulate. In the given AF characteristic and PF characteristic, we delete PF characteristic. In the AF characteristic, we drag the cursor to the vertical axis of 707 milli. The corresponding frequency is 9.88 Hz. Here the resistance is 100 k ohms. The capacitance is 0.16 microfarad. You can verify that the frequency is the same. The second example is a touch-tone phone, also known as a double audio phone. We want to know that when we press any key on the phone, how can the interchanger know we press that key? It involves the use of many filters. Keys are divided into 4 lines and 3 columns. When pressed the first line, the phone will send a frequency, the second line another frequency, and so on. When pressed the first column, it will send a frequency, second, third, so on. That is to say, every time we press a key, telephone will send 2 frequencies. For example, after we press the key 5, telephone will produce 770 Hz and 1336 Hz at the same time. The frequency will be transmitted to the interchanger through the telephone line. After the signal transmitted to the interchanger, it needs to be amplified by op-amps first, and through a LP filter and HP filter. We can see that the cutoff frequency of the LP filter and the HP filters are probably 1 kHz. That is to say, signal of 770 Hz can go through the LP filter, and a signal of 1336 Hz can go through the HP filter. There are 4 BP filters behind the LP filter. That is to say, they correspond to these 4 frequencies, which are less than 1000 Hz. There are 3 BP filters behind the HP filter. They correspond to these 3 frequencies, which are greater than 100 Hz. Specifically, after pressing the key 5, the 770 Hz pass through the LP filter. It also passes through the second BP filter, which is specifically set for 770 Hz. Then there is a signal monitor, so we know that the telephone sends the frequency 770 Hz. There is a similar process for the HP part. We also know that the telephone sends the frequency of 1336. Combining these two, we know that the user pressed the 5 on the telephone. Why do we want to do that? You can find that by using this way, we only need to produce 7 frequencies for transmission and detection. But if we give a frequency for each key, it requires 12 frequencies. In this way, we can save the cost and improve the reliability. Seeing from these 2 examples, filters have a lot of practical applications. Well, this is the end of this lecture.